Hi everyone, this is Mrs. Lehman. I'm going to do a really quick video today. I'm calling it Cram Session for this New York State Grade 6 math test. So I'm going to go through all of the skills essentially you've learned in grade 6, and that hopefully will refresh your memory of everything that you may encounter tomorrow on the New York State exam. All right, so the first thing I'm going to talk about is Module 1. So Module 1 was started with how to write ratios, and again you may see ratios with the word for every, and we had the ratio alert. All right, that meant a ratio was ahead, and we also learned how to write them. So if I said 1 to 3, that's ratio form. You could have written this as a fraction, or you could write that with the word TO, like that. Then we had unit rate, okay, and back to ratios. You can scale those up or scale those down. Your goal really is to make sure that the value of the ratio is maintained. So a value of a ratio is a ratio in simplest form. All right, the next thing you learned was unit rate, and that is when you get a ratio to scale down to be out of 1. So miles per hour is a unit rate. The price per pound of something is a unit price. Anytime you scale it down to 1, that would be a unit rate. And you hear the word per a lot when you're dealing with unit rate. All right, distance was something we learned on how to apply speed to figure out how far you would go, and you just needed to be careful to make sure your units of time were compatible. So we use the formula distance equals rate times time, so how fast you're going for how long, and you multiply that for how long you go that speed. Anytime your distance or anytime your speed changes, you need to restart the formula. Proportions, this should ring a bell. Line equals line, okay? And some of the things we learned with that is part over whole equals percent out of 100, as we talk into the next one, percents, all right? And is over of equals percent out of 100 if you're dealing with percents. But again, you could use proportions to scale up if you know that you have one student who hates math for every 3 total students. Oh man, that's a terrible example to give. Let's say hates peanut butter. If you have one student out of 3 that hates peanut butter, and we wanted to figure out of 60 kids, right? So if I had 1 out of 3, I want to figure out if I have 60 total kids, how many kids hate peanut butter. You got to, again, look at that relationship to get from one side to the other. So we would know that's 20 out of 60 kids. And we talked about the quote, if you can't divide or multiply, you must simplify, because sometimes they may not give you a compatible set of numbers. Maybe they gave you, like, I don't know, something that would simplify down to 1 to 3. But anyway, that's just a quick review of Module 1. Let's go on to Module 2. Module 2 was all about operations with decimals, and specifically as far as, I should say fractions. Multiplying and dividing fractions was a big thing. Remember, multiplying fractions, you just multiply straight across. When you're dividing fractions, you want to copy, dot, flip. Keep, change, flip, drop, switch, flip. Multiply by the reciprocal if you're going old school. LCM, we talked about where numbers first meet. It was a first special occasion that those 2 numbers bumped into each other on the number line. This is something that you see with questions that involve rotating schedules or anything that would follow a cyclical pattern. Then we talked about greatest common factor, which factors are numbers that break down. They're numbers that can be multiplied to give you a product. So we talked about breaking them down in factor trees. We've used T-charts as well. You're looking for the biggest number that is common to both numbers that they give you. Questions that involve greatest common factor include things where you're maybe making teams and you want to make sure you have teams that have the same number of boys and girls, for example. Or in our module, we had a question like how many atlases, dictionaries, encyclopedias, this librarian had, and she was trying to figure out how many tables she could set up that all had the same amount of each on those tables. So anytime you're kind of grouping like baskets, you're grouping kits of something, you're making teams, etc., and it's looking for the greatest number of something, that would be greatest common factor. So we're going to move on to Module 3. How did I skip Module 3? There it is. All right, rational numbers. So rational numbers are any number that can be written as a ratio. So any fractions, any whole numbers, any decimals are all rational numbers. And we talked about where those would go in a number, on a number line. We talked about how numbers to the left of 0 are negative and how numbers to the right of 0 are positive. We talked about inequalities, how we could have less than, greater than, or we could say less than or equal to, greater than or equal to. We talked about words that indicate positive and negative numbers, so above 0, below 0, debt, credit being a positive one. We talked about elevation, below sea level, above sea level. We talked about 0 being sea level, and lots of just number lines, etc. In Module 3, we also learned the coordinate plane, which I should write up here. So we learned about the x and the y axis. That looks like the g axis. We jokingly say there's a z axis, and that's for people who are clueless to this. We talked about the 4 quadrants, quadrant 1, 2, 3, and 4. We talked about how to plot points, x first, then y. We talked about reflections in the coordinate plane. We talked about distance in the coordinate plane and using absolute value to find the distance between 2 points. I told the kids if they don't give you a coordinate plane and you need to do something involving one, DIY it, do it yourself, because sometimes you're not given all of the tools that you may think you need for that. So there's nothing saying that you can't create your own. Moving on. Module 4, we learned about exponents. So 3 squared does not mean 3 times 2, it means 3 times 3. So it's a number, that base, bottom number is the base, that's multiplied by itself the number of times that exponent indicates. So in this case, it's 3 times 3. All right. Order of operations, that's where you guys learned the saying PEMDAS, and we talked about the triage center of the math world and how you need to prioritize the operations in math. So parentheses is always top priority, followed by exponents. Multiplication share the same importance. Next in that order, it's whichever one comes first, going left to right when you get to that category, and same for addition and subtraction. All right, algebra, so much to say here. We've got really the first time we're using letters instead of numbers. So anytime we have an unknown number, we're talking about that being a variable, meaning it's a number in disguise or a number we don't know. And we can use that to represent different scenarios where the number could change. So substituting for a variable was a key skill, so they said maybe a number plus 5, solve it when n equals 7. Right, then you'd plug in 7 plus 5, you would get 12, for example. The next thing you guys learned was how to write expressions, which you had to convert the language, the English language to the language of math, and how to write a sentence using numbers, variables, and operations. So we talked about coefficients. So if we had 4 times a number, you would write that 4n. We learned that if you wanted to say n divided by 4, you could also write it as a fraction here. And we learned things, like sum means the same thing as add, plus. We learned that some of the subtraction words mean decrease by, less than, that's a flip-flop phrase we said, which means the last, like if they said 7 less than n, we would have to say n minus 7, all right, which is different than 7 decreased by n, right? In that case, you don't have to worry about flipping the order of those. Anyway, how to solve equations was doing the inverse operation. So, for example, if you have 3 plus x equals 10. We want to isolate the x. We want to get it by itself, so we're going to do the inverse operation to both sides. You would get x equals 7. And then we learned how to check that, which is back to substituting for a variable. So 3 plus x equals 10. 3 plus 7 equals 10. 10 does equal 10, so we did that correctly. Whew! Anyway, so that's algebra in a nutshell. Let's go to this example that you will probably see on your test, I'm guessing. Write an equation based on a ratio table. So quickly, I want to prove the point that it doesn't matter if you know what they're talking about. They give lots of examples for like plant species maybe, or plant varieties, or like animal species, or things like that. And you don't have to necessarily know anything about it, but you have to recognize it's a ratio table. And I use the example from the Little Mermaid, the Little Mermaid, who's its and what's its. So let's say you have 2 who's its and 12 what's its. What's the relationship between the two? So if you need to write this as an equation, right, what do I have to do to this column to get this column over here? So you'll probably notice right away you have to multiply by 6, right? So the number on the left times 6 will give you this number on the right. So you can find missing numbers here. And another thing that you'll sometimes be asked to do is, you know, like I said, write it as an equation. So let's say this is x and this is y. So to get to get y, you have to take your x value and multiply it by 6, right? So you want to write x dot 6 equals y. The more grown-up way to do that would be 6x equals y. And actually, a lot of times you see y equals 6x written with the y first. Anyway, another thing that you may see with something like this is you just need to turn these into coordinates and plot them. And there you go. So if you had the flower horn and the arowana, I don't know if I'm pronouncing that correctly, but if it's anything like anything else I pronounce, it's probably incorrect. So the flower horn and arowana are different exotic fish species that you may find in a fish tank, I'm guessing. So again, the point is it doesn't matter what they're talking about here. You just need to look at the pattern between the numbers. You'll notice that that arowana are always consistently less than the flower horn, so that means they're using division, right, to get from one side to the other here. So 10 divided by 5 equals 2, 15 divided by 5 equals 3, 60 divided by 5 equals 12, and 75 divided by 5 equals 15. So if I wanted to say this was x and this was y, the relationship between the two would be you take your x value and you divide it by 5 to get the y. All right, so I'd write it like this: y equals x over 5. All right, just to give you a few examples. And again, you could be asked to write those as coordinates and then graph them. All right, anywho, I need to move on because my goal is to have this video be short. So we still have 2 more modules to cover quickly. Module 5, we learned about parallelograms, triangles, nets, and volume. One thing with parallelograms and triangles, we learned that the height is perpendicular to the base. So we're looking for that little box indicating a 90-degree angle or a right angle. And with parallelograms, a lot of kids mix that up with the side length, which you need the side length for finding perimeter, but when you're finding area, you need the height, all right? And triangles, same deal, okay? So for a parallelogram, the area formula equals base times height. For a triangle, it's base times height divided by 2. And if you're using fractions, I'd recommend using area equals 1/2 base times height. Nets are used for when you're breaking down a 3-dimensional figure into a flat series of shapes. All right, so the key thing with nets, they have to close, they have to really fold up and actually close, I guess. So one thing that you may have to find with right rectangular prisms is the surface area. So they may give you a picture of a right rectangular prism, and you have to realize that even though you can't see the back, there is a back to this shape. And even though you can't see the left side, there is a left side. And even though you can't see the bottom, there is indeed a bottom to this. So you'd have to break that up into those things, label it, find the area of each. So for example, it's a BOGO sale, right? If you find the top, you also found the bottom, right? Find the right side, you've also found the left, and same with top and bottom, all right? Now that's for surface area, and that means how much wrapping paper, for example, would it take to cover that. Volume, on the other hand, is what's the capacity of this box, how much could it hold, how many 1 inch by 1 inch by 1 inch cubes would it hold, how much space does it take up. So you would just use the formula volume equals length times width times height. They love to ask questions where you fill it with either smaller or larger cubes. So for example, if they said how many 1/2 inch cubes would it take to fill the same thing, you'd first of all do 2 times 3 times 7, right? So you'd get 6 times 7, which is 42. But then you would need double the amount here. You would need double the amount here if they were 1/2 inch cubes, and you need double the amount here. So you don't just double 42, which is a common mistake. You actually have to multiply that number times 2 times 2 times 2, which would be 8. So 42 times 8, which would be 336 cubic, or 1/2 inch cubes to fill it. But the volume of it would remain the same. It's still a 42 cubic inch rectangle. All right, and that was the last module. So anyway, I'm a little over 15 minutes, but check out my other review videos if you can tonight for state review, state testing review. You guys have done a really good job. I think you will do just fine. But thanks for watching. Have a great day. Bye.